I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in Austin, Texas with StorMagic. Around the table are a group of invited writers and speakers from around the world to ask questions and learn about the products. If you'd like to learn more about our event, just go to techfieldday.com, and you can find many more videos like this at youtube.com/techfieldday.
The first most important thing to say about us is we're a software company, software-defined storage. Now, it's a term we all know, but it's a term that has been misused for quite a while. The principle of what we do is to keep everything in software and keep it independent from hardware. That's where software-defined storage started. But it's now tended to have been stolen, brought into hyperconvergence, and people are using it to tie you into buying hardware. The principle of what we do is to free you from the hardware and allow you to use any hardware you particularly want. Our focus is very different to other companies in the software-defined storage field or in the hyperconvergence field, where we aim at what we call the edge of the enterprise. Smaller locations, it could be a very, very large enterprise, but they have multiple smaller locations, and they want to be able to have the benefits of software-defined storage, the benefits of virtualization, the benefits of high availability in those remote locations, but without the cost that is typically associated with doing all of that. They probably don't have any IT resources in these locations. It may take them days to get someone there. We handle locations like oil rigs, wind farms, in hostile environments, military applications, where you're not necessarily going to have IT people. That's typically where we focus. So large organizations, small organizations, multiple remote locations, they want ease of management, they want virtualization, they have to have storage to go with that, and our technology fits very nicely in that for them. So effectively what we do, the base of what we do, is eliminate the need for what used to be called a physical SAN previously. If you are going to virtualize, if you have multiple servers, you want shared storage, of course. And that used to be provided by a physical SAN. The problem with the physical SAN is it becomes a single point of failure in its own right. It can be extremely costly. It's fine if you have a lot of data. A lot of our customers have 2 to 4 terabytes of data in each one of their locations. That's a fraction of a disk drive. That's a laptop these days. Why do you want a physical SAN for that? You want shared storage. You want high availability, but you don't want the cost of the expenditure associated with physical SANs. So the way we do that is we take the storage, that could be hard disk drives, that could be flash, could even be memory, within the servers, and actually make that available to our software, share that, and make it available as a virtual SAN. Quite simple. Typically, this is going to be used in, as I mentioned, large enterprises with multiple remote locations. I'll give you some examples later on some of our customers and how they're using the technology. It could be used by an SMB, or it could be used to store large volumes of data as well, which is relatively new applications that our technology is being used with. I'll give you some examples of that later. So, how widespread are we? Well, we're used across 72 countries today. We have thousands of customers. Our largest customer has over 2,000 locations. We're used across many verticals, and I'll give you examples of those verticals later on as well. So thousands of sites, and our technology is available through a partner network that is global. We have a strong partner with us here today, Cisco. Our technology is available, our software is available on Cisco's price list, and available to use on a range of their platforms. We'll give you more detail of that later on. So the base principle of what our technology actually is and what it looks like, you have 2 servers, and 2 is actually quite important. We're the company that really pioneered the capability of having high availability in a virtual environment on 2 servers rather than the 3 that the industry typically needed. Other companies are now trying to do the same thing as well, but we pioneered this because our customers, if you've got 1,000 locations, the cost of a 3rd server in each one of those locations is very, very expensive. So we pioneered the capability of doing that. You have 2 servers. We have a 3rd device we call a witness device, NSH as it's called here, neutral storage host, which actually acts as an arbitrator. If there is any particular problem on one of the servers, it actually is the voter that decides which one of the servers is going to take over control of the data to make sure you don't get data corruption. And this is typically centralized. That customer with over 2,000 locations runs that from one central point, monitoring all their 2,000 locations. If the communications to the center fails, then there's a lot of technology built in as well to detect particular failures and to avoid situations like split brain actually happening. So there are other protections built in. So being able to do this in 2 servers brings your costs down straight away, makes it easier to actually manage. The management capability, if you're in a VMware environment, will be done through vCenter typically. It could be done through our web GUI if you want it as well. But that's typically in the center, where you can see all of the sites and manage all of those sites, update all of those sites if you want to from the center, push out actually updates to it. You can script that capability if you want to as well. Luke will go into a lot more of the detail of that for you later. The key thing it actually does is it provides to you high availability. There is no single point of failure. Before this configuration, where you would have had a physical SAN, if that physical SAN failed, you lose everything. In this configuration, there is not one single point of failure. You can lose server, you can lose storage, everything remains there functional. Everything fails over to the second remaining server. So what sort of use cases are we used in? Well, remote office branch office is where we've made our name. We have a lot of very large companies using us in those applications. Applications like retail, I mentioned oil rigs. It's where we've made our name previously. One of the main functions that people are looking for is high availability, being able to survive any form of failures. The effect of a business of a failure can be catastrophic. If it's a retail environment and someone can't buy something at the cash desk, they're not going to wait long. They're going to leave. They're going to go to the competitors. You've not only lost that sale, you've probably lost that customer as well. The effect on morale, the effect on earnings. There's one customer that we had that was actually suffering approximately 2 failures a week across their network, very large network of stores. That 2 failures a week, each failure typically lasted about 6 hours. Each hour cost their business, not including the ancillary costs, about $25,000. That's a lot of money they were losing because of failures of the systems on site. So high availability is very, very important to them. It's important to protect revenue, it's important to protect reputation, it's important to protect morale, and it needs to be capable of being provided cost effectively. We're used by our partners to build hyper-converged platforms. Cisco, for instance, have a range of solutions based on our software, from very small to large, that I'll show you later, using our software to provide software-defined storage as the basis of that. End-user computing environments. Hosting and managed services, we're seeing a lot more business over the last year or two in that particular environment. And a very large growing sector for us is industrial IoT. In fact, it is, I think it was IDC who actually said that within the next couple of years, 40% of the data is going to be processed at the edge. So where a lot of people for the last few years have been saying to me, why is your technology relevant when everything's going to be centralized? It's actually going the other way. With more and more applications at the edge, with more and more things that need to talk to each other and act on the data there, more of the processing is being done at the edge, and only the important metadata based on it is sent back to the center. So the type of verticals that we have been involved in, retail has been our biggest vertical for quite a long time. There's a lot of retail stores here in the US and globally that have been using our technology. It's probably where we made our name. Government, defense, battlefield communication systems. The German army have been using us for a good few years now. Literally, these are boxes that they would drive or drop into the middle of the battle zone that would handle all of the communications. Obviously, high availability is important, and obviously you don't want to send an IT guy in with that either. So you can see a common thread in a lot of the applications we deal with. They want simplicity, they want ease of management, they want high availability, and their application must run. It cannot fail. Energy, I mentioned some of these earlier, wind farms, oil rigs. We have a few companies we actually work with for oil rig management systems. Typically, previously, they had to actually fly disk drives on a daily basis to process the data back to a central hub. Now they're actually moving a lot of that capability onto the oil rig itself. Healthcare, hospitality, hotel chains, restaurant chains. In fact, a growing sector for us is fast food outlets. You'd think there wouldn't need to be a lot of processing capability in a fast food outlet. I won't mention any names. I'm not allowed to mention names, so I won't. But you guess your own fast food outlet, and you'd be quite surprised at the amount of service and processing capability that they need. They don't have IT people. They don't have a lot of data, but they have a lot of apps that they need to be capable of running. Even just in telling people, flip that burger now. All of that is automated. And all of that, if it doesn't work, they can't serve the customer. So, a few case studies. Here in the US, a large department store. I'd love to mention the name. You can probably take some good guesses at who it is, but we're not allowed to actually mention the names. This department store, previous to our technology, they installed our technology about 2 years ago. They were running on 2 servers and a physical SAN. This is not the one that was getting 2 failures a week, but they were getting relatively frequent failures as well. And if that failed, the store effectively went down. They could not service the customer, and it severely affected their reputation. They, working with Cisco, they installed UCS 240 racks, 2 UCS 240 racks. There were 12 drives in each. Used our software to provide the shared storage on that, and eliminated all of the downtime. An interesting side fact that they actually benefited from, by reducing down to 2 servers, they were already virtualized before our technology was brought in. By reducing down to 2 servers and eliminating the SAN, they actually reduced their energy budget by $300,000 a year. So the energy for powering the SAN, the energy for cooling the technology that was there, they estimated a $300,000 savings a year. So there's other advantages that come in using our technology as well. This is another interesting case study. It's another one that we partner with Cisco on as well. You may also take a guess on what this company is. I was going to give a hint, but I better not. There's too many people watching online at the moment. On-demand services. This is basically a service that people would actually request. They expect to arrive relatively quickly, and they expect a capability to know what's going on while that service is actually provided. That could be monitored from the center. They were finding in some of their remote locations, due to failures within their servers, that they lost that monitoring capability, and that, because of the service they provide, could be catastrophic. Working with Cisco, we've moved in UCS servers, C-Series servers again, using our software, and they have eliminated that downtime. They don't have IT personnel in these remote offices. Everything, once more, managed from the center. They know it's reliable, it's working on the outside. They can actually install from the center, upgrade from the center, keep their costs down, keep their manageability high. Another interesting one, and a much smaller application. This is an auction system here in the US. They have spread right throughout the US in quite a lot of, I wouldn't say quite remote, but not as accessible locations. Not a lot of data, but if they suffered a failure while they were going through that auction process, it cost them a lot of money to recover from that and send someone to site. In this particular application, we're working with UCS E-Series. For those who don't know UCS E-Series, it's actually a Cisco ISR router, and then the E-Series is a blade that can fit within that router. So you have one box, you have the router, the compute, the storage, all in a single box. Their capacity requirements was only about 1 terabyte. They didn't need a lot of data. So they put in 2 UCS E-Series. They have high availability across it using our software. They now don't have any failures anymore. Another very different one, and this is going the opposite scale. So I mentioned the UCS E-Series, which typically would have 2 disk drives involved in it. This is based on the new S-Series product from Cisco, which we'll mention a bit about later as well. This has up to 600 terabytes of data at the moment. We have a couple of customers using this in these applications. Why? In these large data applications, this is actually a hosted environment. In these large data applications, the most important thing they actually want is recovery across a couple of sites. So they're using our mirroring capability across 2 data centers that are a distance of kilometers apart. When I say kilometers, I'm talking typically 5 to 10 kilometers. And they're actually active mirroring the data on both sites at the same time. They're using our software for that capability with a data farm of 600 terabytes underneath our software. So not where you would have presumed our technology to typically be, but it has the same desires and characteristics of simplicity, high availability, active is very important to them, and ease of management. They don't need a huge amount of functionality on top of the basis of what they want that product to actually do. So then, we have a strong relationship with Cisco. It's been running for the last couple of years. We're on Cisco's price list. We're available to work with a lot of the different platforms from Cisco. We're supported directly by Cisco. Our engineers obviously work with Cisco as well if there's any further in-depth problems that are actually required. But it means that our customers can actually go to Cisco, build a solution that fits their particular environment, or a range of solutions if their environment varies. We've one supermarket chain that has some very large stores, and then it has some convenience stores. They can pick a solution that's suitable for each of the different size of environments, and they can order that directly from Cisco with support from Cisco. And this gives you an idea of the range of servers that are available for that platform. So first of all, with the UCS E-Series, I mentioned that. That's an ISR router with the blades, and these can be single or dual wide. It can either take a single blade or dual blades within these models that take one or the other. The UCS C-Series racks, available in different sizes to fit capacity and performance requirements. There's the UCS Mini, which is an 8-blade box. Our software actually runs on each of the blades and actually amalgamates all of the storage that is on those blades. And the more recent release, which is doing quite well for us and actually surprised us how well it is actually doing, the S-Series, which currently has about 600 terabytes of data. How many disk drives? Up to 60. Up to 60 disk drives available within that box. So that is the background for us. I'm going to hand over to my colleague Luke, who can get into the stuff that you probably really want to hear about, how the technology works, what it can do for you, and the advantages of it. Thank you very much for listening. Any questions? Yes?
Yeah, is any reason you didn't certify the B series? It's more or less the mini one. I mean, UCS B series.
Yeah, so basically, what we're aiming at is the entry-level solution. So typically aiming at a minimum 2-server configuration. The odd one out on this list here, which is probably why you asked the question, is the UCS Mini. And the main advantage of us on the UCS Mini is that each of those blades had 2 disk drives which couldn't be used. The data couldn't be shared. So by installing our software, it made all the storage available on those blades shareable. But besides that, really what we're targeting with Cisco is entry level. So that would be 2 E-Series, 2 C-Series, 2 S-Series, rather than larger data center type environments.
Yeah, thank you.
And do you have any compatibility list which is possible to use with your software?
A compatible list?
Yeah.
So do you mean other hardware besides Cisco?
Yeah.
The benefit is that any hardware that's actually available on VMware's hardware compatibility list, we support. So it's most unusual for VMware to do some work for us, but very kindly they actually test all of the hardware, and if they tested the hardware, it works with our software.
Okay, fantastic. Thank you.
Cisco's a great partner, but we really, when it comes down to it, this runs on any hardware, as long as it's on the hardware compatibility list.
I won't listen to this. Thank you.